Okay, so today I want to talk about the last section, section 5.3, the volumes by cylindrical shells. This is the outline. I want to explain how we can find the volume by cylindrical shells. Second one, I want to give examples. Third, how can you choose disk method, washer method, or today title, method of cylindrical shells. The last, I'm going to give the more examples. Here, some volume problems are very difficult to handle by the methods of the preceding section, the cross-sectional method is right. The washer method or disk method, they're not easy. I can show one example. Find the volume of the solid obtained by rotating the region bounded by y equal to 2x squared minus x cubed and y equal to 0 about the y-axis. Here, this is like a graph, this one is right. How can you sketch the graph? You can use this idea. Here, you can do factor. You can do factor. This one, the 2x squared minus x cubed. You just only factor out x squared. So we have factor out x squared, the 2 minus x. The x-intercept is 0 and 2, right? We have x-intercept intercepts 0 and 2. You can draw the graph. The graph is passing through 0, passing through 2. One more. What happens like 0, we have even power, just a touch. The power is like 1. What does it mean? Cross. Graphs like this. So we have this one. So like this one. Here, the slice solid, the perpendicular to y-axis, we have this kind of solid, this one. You have to rotate this one. What happens? You have to rotate this one. Inside one has small circle. The outside has big circle, like washer. We have a washer. To compute the inner radius, the outer radius of the washer, we have to solve the cubic equation y equal to 2x squared minus x cubed in terms of y, because this one is, you have to find solve this equation for y, to change y. Same, this is, you have to solve this equation for y, but not easy. It is very difficult. So we cannot use the washer method. We have an easier method for solving this problem. Today title, method of cylindrical shells. So how can you use this kind of things? Here, I want to analyze this problem. Before we are going back to this problem, we think about how can we find area, the volume of cylindrical shell. So we have the inside the cylinder, outside the cylinder. So exactly between two cylinders, we have cylindrical shells. The R1 is inner radius, is right, this one. Inner radius, this one. R2 is whole thing, outer radius, this one. The H is height, this one. This one, height of a cylinder. R is like R1 plus R2 over 2. Exactly here, you choose midpoint and connect. This is like R. This is R. The average radius of the shell. Delta R is thickness, exactly R2 minus R1. This is delta R, the thickness. The V1 is the volume of inner cylinder. The V2 is volume of the outer cylinder. How can you find the volume of the cylindrical shell? This is exactly the outer cylinder minus inner cylinder is exactly volume of the cylindrical shell. So how can you find the volume of a cylinder? You can use a formula, the base times height. The base circle exactly pi r squared times h. The radius of V2 is R2, exactly pi R2 squared times h. The V1, the radius is like R1, the pi times R1 squared times h. Like this. The next, you just only factor out common factor pi, common factor h. So we have it. Next factor. The R2 square minus R1 square is R2 plus 1 times R2 minus 1. So we need some algebraic trick here. The R2 plus 2, you can change 2 times R2 plus 1, R2 plus R1 over 2. You can change it like this. So you can rearrange it. To just like outside the 2 pi here. R1 plus R2 over 2 is exactly the average radius. So change R. R2 minus R1 is here is exactly thickness. So, delta thickness. This one. The H is height. So what's like a 2 pi r? The 2 pi r is circumference. You can choose this radius. You can draw one circle between the outer cylinder and inner cylinder, like a middle one. This middle one. This is like a circumference. Circumference is 2 pi r. Delta r is the thickness, h is height. You can rearrange it exactly. Circumference times height times thickness. So this is exact volume of cylindrical shell. What's that? The circumference 2 pi r times height h times the thickness delta r. Just like idea. We are going back to the general problem. The lead acid with a solid obtained by rotating about the y-axis. The region bounded by y equals f of x, where f of x is greater than y equal to 0 above x-axis. The y equal to 0, x equals a, x equals b. We have this inequality. The b is greater than a is greater than y equal to 0. So we have this one, this region, like this. You have to rotate about y-axis. Rotate about y-axis. We have this kind of solid. This is S. The solid is exactly S. S. How can you find the volume? The idea is like this. Step 1, divide AB into n sub-intervals x1, x0, x1, x1, x2, xn minus 1, xn of equal width delta x b minus a of n. And choose sample point xi star is a midpoint xi minus 1 plus xi over 2. Step 2, to make n rectangles with base equals delta x. And height is f of xi star and rotate each rectangle about y-axis. So what does it mean? The step 1 is like this. You can divide this one by n sub-intervals, like this, right? And make this one cut. You have to cut, like this. You have to cut. You have to cut, like this. You have to cut. The next one, was like this one. This is exactly delta x, b minus a of n. So one example, this point is, we can denote the x I minus 1, This point is like xi, like ith interval. So you choose xi star. Xi star is midpoint. The midpoint. So this point is xi star. The next, you can make a rectangle. The rectangle is the approximate of this strip. Here you can cut, make flat like this. You can make this rectangle. We have some error. Next, you have to rotate this one about y-axis. You have to rotate this one about y-axis. What happens here? So we have this one. We have rotate this rectangle. We have cylindrical shells. We have cylindrical shells like this one. So what's that? This point is here, middle point. This point is this one. This point is this one. Exactly, this one is like a rectangle, center rectangle. We have cylindrical shells. So you can move this one to the here. What happens? Perhaps like this. We have this kind of a yellow one. The exact thing is here, exact one. You can make a rectangle rotate, only cylindrical shells. We have n-cylindrical shells because we have to rotate n rectangles. So with the average radius xi star, height is f of xi star, the thickness delta x. So here, this middle point is not xi star, this is xi star. The volume of ith cylindrical shell is the 2 pi xi star times the height f of xi star here. This is f of xi star height. The delta x is exactly this one, thickness. Thickness is delta x. The next, approximate the volume of S by sum of volumes of these shells, like this. Summation I equal to 1 to n, 2 pi xi star times f of xi star times delta x. You can add it. All cylindrical shells, like this. So we have error. We have some errors here, some error. Here, some error. This one, we have errors here. This is error. This is like error. How can you reduce error? We can use step 4. This approximation appears to become better as n approaches infinity. What does it mean? You have to increase the number of subinterval. Increase number of subinterval, like number of the width is decreasing, automatically error is decreasing. What's like exact volume? The take limit, n is going to infinity, summation I equal to 1 to n, 2 pi xi star times f of xi star times delta x. You can change this one to the integral form. So n is the limit and summation is going to integral from a to b. Keep 2 pi. Xi star is going to x. F of xi star is going to f of x. The delta x is going to dx. That's it. This is the whole idea. Like this. So in this case, the rotating axis is just y-axis. Sometimes rotating axis is any vertical line. So you cannot use. You can think about what's like lower. This x is exactly radius here. This is x is here. Half. This is radius. Average radius is like lower x. So x is like radius of cylindrical shell. This is like lower of radius. What is f of x? F of x is this one, exactly height. So f of x is lower of height. Dx is like a thickness, the lower of thickness. This one, you can memorize. This is better. Integral from A to B. You can make a cylindrical shell. The 2 pi times radius of a cylindrical shell, the height of a cylindrical shell. This is like exact formula. The formula for finding volume. And apply this one to the same problem. Find x-intercept. The 2x squared minus x cubed equal to 0. The factor out x squared, x equal to 0 and 2, the exact same to previous example. The intersect the region by a line parallel to the rotating axis. Make a rectangle, rotate the rectangle about y-axis. So we have a cylindrical shells. So like this, right? So what does it mean? So here, I can explain these kind of things here. We have 2x intercept, 0, and 2. Graph is here, always touch this one and move back like this. This is like region R, the region R. So intersect this region R, a line parallel to the rotating axis. The rotating axis, this one, you have to cut this segment by using X. So next, make a rectangle. What does it mean? Make a rectangle. This one, make a rectangle. You have to rotate this rectangle about y-axis. You have to rotate this rectangle about y-axis. What happens? So this one has one cylindrical shells, right? Look, rotate this one. So we have here. Inside one has small circle. The outside has bigger circle. So connect. We have this one. Inside one is like this. We have it. Like this. So we have it. This kind of things. What's the volume? The integral a to b 2 pi times radius height. You can use formula of a cylindrical shell. So what's that? Like this. So what does it mean? Here I can write one more. This is like integral a to b 2 pi times what's the radius? The center is always rotating axis. Connect this point. This is the same to, yes, same to the x. So radius is x. What's the height? Height is here. The function value on the curve, exactly 2x squared minus x cubed. Like this. So we have it. You have to expand. Find antiderivative. 2 pi, the 2x cubed. What's integral 2x cubed is exactly what's like the integral of 2x cubed. This one is 2 times 1 over 4 x to the 4. The 2 is crossed out, x to the 4 over 2. Integral of x to the 4 is x to the 5 over 5. You plug 2, you can plug 0 is 0. And simplify. The 2 is crossed out. The 2 pi times 8 minus 2 to the 5 is 32 over 5. So like this. To simplify, we have 16 over 5 pi because the 8 is same to 40 over 5. 40 minus 32 is 8. 8 times 2 is 16. You got it? This is a whole idea, right? By using cylindrical shells. Here, next one. Find the volume of the solid obtained by rotating the region bounded by y equals x minus x squared and y equal to 0 about x equals 2. How can you sketch the graph? You can use same things. First one, you can draw y equals x minus x squared. This is the same to factor out x, the 1 minus x. So you can find x-intercept. X-intercept is, what's x-intercept? Could you write your answer on the chatting board? What is your x-intercept? Do you know what is x-intercepts? Could you write your answer on the chatting board? Yeah, you're right. Exactly. This one equal to 0. You solve x times 1 minus x equal to 0. X is 0 and 1. Yes, we have 2 points, the 0 and 1. So what's the graph? So we can just sketch the graph. We have 0 and 1. The one more. The coefficient of x squared is -1. Graph is open down. Graph is like this. The y equal to 0 is this one. We have this region. So I can write here again. So what's that? So we have graph is like this from 0 to 1. This is same to y equals x times 1 minus x. So one more. Was it like rotating axis? X equals to 2. We have here x equals to 2 is rotating axis. You have to rotate. So what's like the best way? You can use previous method. You can choose x value here. Choose x value. You can cut this region. We have a segment. You can make a rectangle. Rectangle, this one. You have to rotate this rectangle about x equals 2. You have to rotate this rectangle about x equals 2. So what kind of shape do we have? So we have cylindrical shell. We have cylindrical shell. This one. Was it like this rectangle? Exactly this portion. This one is same to this rectangle, the same. So let me see. How can you find the radius? The radius is this one. I can use blue one. What's the radius? The radius is centered here. What's that? This one is exactly, the center is exactly same to what? X equals 2. This is what? X equals 2. 2. You can connect to the average radius here. This one, you can connect to the average radius. Here, this length. This is radius. So, what is this radius? What's that? What's that? So could you write new answer? What is this length, radius? So could you write new answer? What is radius? This one. Do you have it? Is it 1? 1 is here, not 1. This x is like change it. Here, you can find this length from here to here. This length. How can you find this length? So let me see. What is this length? What's that? What's this one? From here to here. What's that? This is 2. Is it 2? What is this one? This one, x. Same to this length, like x. So what is this one? The 2 minus x. This is 2 minus x. So we have 2 minus x is radius. Radius. Next one, height. Height is from here to here. This is a height. I can use this blue one. This is a height. We are going back to this one. This is a height. This is a height. What's that? This is a height. What is length? What's that? This one. So could you write your answer? What is length? What's that? What's height? So do you know height? So this height is exactly function value on the curve. Function value on the curve is this one. Y value, x minus x squared. This is x minus x squared. So we have x minus x squared is height. this one. So what's like a volume? Integral from A to B, the 2 pi times radius times height dx. This is the idea. So integral, what is A? So here, the A is 0. 1 is B. 2 pi times radius is this one, 2 minus x. 2 minus x. What is the height? Height is x minus x squared. dx. So that's it. This is the whole idea for solving this problem. Like this. This one. Like this. This one is 5/2. I don't calculate. Algebra calculation is up to you. Though we have this answer. Like this. The next one. So how can you choose disc washer method or cylindrical shell? How can you choose? So I want to give the one example, the one good thing here. Find the volume of the solid obtained by rotating the region bounded by y equals f of x, y equal to g of x equals a, x equals b. The g of x is the less than y equal to f of x, a is less than y equal to b about a specified line. So cross section is the perpendicular to the rotating axis. The height of the cylindrical shell is parallel to the rotating axis. We have two kind of things. Case one, the rotating axis is horizontal. So this is like a key. The rotating axis is horizontal line. So we use disc or washer method. The cross section is a disc. AX equals pi times radius squared because disc is like a circle. Or the cross section is washer. The AX is pi times outer radius squared minus inner radius squared. You can use this formula. Volume V equals integral from A to B, AX dx. Second case, the rotating axis is vertical line. The vertical line, you choose method of cylindrical shell. This is the easiest way. The volume is integral from A to B, 2 pi radius height dx. This is the key. The cross section is always perpendicular to the rotating axis. Height of cylindrical shell is always parallel to the rotating axis. Always parallel to the rotating axis. Here, one more. Find the volume of solid obtained by rotating the region bounded by x equals f of y, x equal to g of y, x equal to c, x equals d, the g of y. So wait a minute, this is like a typo, I think. Sorry. Y equals to C, Y equals to D. Sorry about that. This is a typo. Y equals to C, Y equals to D. The G of Y is less than Y equal to F of Y. C is less than Y equal to D about a specified line. So cross section same. The cross section is always perpendicular to the rotating axis. The height of the cylindrical shell is parallel to the rotating axis. The case one. The rotating axis is horizontal, so we use method of cylindrical shells. The volume V is integral from C to D 2 pi radius times height times dy. Case 2, the rotating axis is a vertical one. Use disc or washer methods. Cross section is disc. The AY is pi times radius squared. the cross section is a washer. AY is pi times outer radius squared minus inner radius squared. Find V is integral from C to D AY dy. This is like idea. I'm going to give one example. So what's like the best one? So you can memorize. The second part is, usually we don't use a lot. Here, this one. Rotating axis is horizontal one. Use disk and washer method. The rotating axis is vertical line. The method of a cylindrical shell. This is like exactly this method. Usually we don't use this one a lot. Here, find the volume of the solid obtained by rotating the region enclosed by y equals 2x and y equals x squared about the x-axis, right? What's it like a graph? The graph is like this. Here, so we have graph. Graph is this one. Y equals x squared. Y equals 2x. Like this. Find intersection point. This region. We have this region. Intersection point is, you can just solve like this one. The 2x equals x squared. So subtract 2x, x squared minus 2x equal to 0. The factor out x minus 2 equal to 0. X is 0 and 2. We have this is 0, this is 2. So let me see. What's the rotating axis? The rotating axis is x-axis. Here, rotating. This is the reason about x-axis. You can check. The rotating axis is, what's that? Yes, horizontal. You have to use disk and the washer method. This is idea. Again, disk and the washer method, you have to cut. You have to cut this one. The X. You have to cut this region. We have this blue one. The blue one is cut from here to here. This is segment. The next, you have to rotate. This is segment about x-axis. This one has one, the big circle. This one has small circle, right? This one has one, the big circle, like this. This inside one has one small circle. We have washer method. You have to rotate segment about x-axis. We have one washer. We have washer. Like this. This part is same to this one. From here, what's like outer radius, inner radius. Outer radius is users only. I'm going to use this one. The green one. From here to here, this is outer radius. We have here to here, this is outer radius. Outer radius. What's that? So could you write your answer? So what is outer radius? What is this length? So what is this length? So what's that? What's the length? So this point is exactly on the line. What's the equation line? Equation line is 2x. We have exactly 2x. So outer radius is 2x. This is outer radius. The next one, I can use orange one. Orange one is from here to here, only inner radius. What's inner radius? From here to only here. So this one. What's that? The point on the curve here, point on the curve is x squared. This is x squared. So inner radius is x squared. So was it like area of washer? Area of washer is, you can use V of x. You can use here the V of x. The V of x is, what's that? Pi times outer radius 2x squared minus inner radius x squared squared. Was it like a volume? The volume V is integral from A to B. A is 0, B is 2. From 0 to 2, the V of, A of x, not V of x, sorry about that. The A of x, the cross-sectional area is pi times the 2x squared minus x squared squared and dx. This is the whole idea for solving this problem. So like this. Right? So like this. So we have it. I don't calculate. The calculation up to you. The 64 over 15 pi. So we have this one. The key part is you have to set up like this. This is like a key. It's like a key. The second problem. Same graph. Only difference is rotating axis, y-axis. What's that? I don't find intersection point. Again, no, I don't find anymore. The graph is like parabola. This is y equals x squared. We have line. So we have line. So this line is y equals 2x. This is 2. This is 0. The same things. The rotating axis is y-axis. What is like rotating axis? Vertical line. Here, vertical line. Exactly, vertical line. The rotating axis is vertical line. You have to use method of a cylindrical shell. This is like a whole idea, vertical line. You can use cylindrical shells method. Oops. So here, what's that? Same. You can choose X and cut the segment. We have to use the same segment. So same segment is, I can use blue one. You have to cut. So like this, you have to cut. You can make a rectangle. You have to rotate this rectangle about y-axis. Rotate this rectangle about y-axis. We have cylindrical shell. Cylindrical shell. So this rectangle is exactly this portion. This portion. So let me see. How can you find volume by using cylindrical shell? Exactly here. The integral from A to B, 2 pi times radius. The radius of a cylindrical shell times height. Dx. This is the idea. So let me see. I can use green one. So what's it like radius, center? The center is always rotating axis. This is like rotating axis here, same rotating axis. This one. The rotating axis is, I can draw the red one. This y-axis, same. This is rotating axis, y-axis. Green one. Here, center is this one. You can connect to the middle point. This is radius, average radius. From here, connect to the rectangle, this middle point, this one. What is this length? So was it like this radius? 2x? 2x is a height. The radius is from here to here. What's that? X. This X. Radius is X. What's the height? Height is this orange one. Height is this one. Height. Same to this one. This one is height. What's that? This point is, yes, this is like 2x. What is this value? What's that? What is the value? The 2x is this one, is right? This point. Yes, this is x squared. This is x squared. So what's it like height? Height is from here to here. Exactly 2x minus x squared. This is 2x minus x squared. So what happens? Integral from 0 to 2. We have 0 to 2. 2 pi times x times height is 2x minus x squared dx. This is like idea. So how can you solve? Like this. So I don't calculate. Calculate is up to you. There you have it. This one. The next here. The same problem, only difference is y equals negative 2. So how can you do that? So you can draw y equals 2x, y equals x squared, find the intersection point, 2x equals x squared, find the intersection point, x in the 0 and the 2, the exactly same to previous examples. So we have equals to 2 minus 2, so we have this one. Here, graph is, this is y equals x squared. This line, the line is the y equals 2x. 2x is a line. We have this region. Intersection point, same, 0 and 2. We have this region. So let me see. What's the rotating axis? Y equals negative 2. Here, y equals this one, negative 2. Rotate about the what's the rotating axis? Horizontal line. Horizontal rotating axis. The rotating axis is a horizontal line. Which method do you use? We always use washer or disc. You can use disc or washer method. Disc or washer. How can you find disc or washer? We can use same segment. Here, you can choose, I can use blue one. You can choose x value between 0 and 2 and cut. Cut this region from here to here, this region. You have to rotate this segment about the here, y equals negative 2. This one has big circle, this one has small circle. So we have this kind of thing. So we have big circle and small circle, but this portion is from here to here. What's the center? Center is this one. Center is always rotating axis. So what is outer radius from here to here? Here to here, outer radius, you can connect this point to this longest one. You can connect this one. This one. So what is this length? What's that? Could you run your answer on the chatting board? What is the length? What is outer radius? What do you think? What is length? X minus 2. Really be careful here. What is this length? What is length? What is length? 2, because this is like a negative 2. Length is 2. Length is 2. Here, what is this length? Exactly function value on the line. We have 2x. Exactly 2 plus 2x. Here, 2 plus 2x is the exactly outer radius. 2 plus 2x. So one more. So what is orange one? This inner radius from here to here. This one, what's that? Center is rotating axis, only connect to the here, this point, this one. What's that? So similar. What is this value? Yes, 2 plus x squared. Thank you. So this length is, this is like a function value of x squared. This length is also 2 plus x squared. So what is like a volume? V inner from A to B. A is like 0 to 2 times the A of x, the pi times inner radius 2 plus, outer radius 2 plus 2x squared minus inner radius 2 plus x squared dx. So that's it. This is the idea. And solve. So like this, simplify, solve. I don't calculate. The calculation is up to you. So key part is you have to set up the like this. And the setup the like this. This is the key. Okay, the next one, another one. Find the volume of the solid obtained by rotating the region enclosed by y equals 2x, y equals x squared, about the x equals negative 2. The negative 2. So how can you find? So we can use this idea. Y equals 2x, y equals x squared, same, the exact same graph. So we have this one, parabola and line. This line is y equals 2x. This parabola is y equals x squared. The point is 2 and 0. 2 and 0, we have this region. Same. So let me see. What's the rotating axis? X equals minus 2. We have here x equals negative 2. The x equals negative 2 is rotate. The rotating axis is vertical line. The rotating axis is vertical line. You have to use the volume, just like method of cylindrical shells. The method of the cylindrical shells. I can use blue one here. You can choose x value same and cut. This is all the same. You can cut this segment. You can make a rectangle. You can make a rectangle. You have to rotate this rectangle about x equals negative 2. You can rotate this rectangle about x equals negative 2. You can only rotate like this. We have cylindrical shells. We have this one and this one, like this. We have cylindrical shells. This one. The where is rotating axis. The rotating axis is exactly same to x equals negative 2 here. X equals negative 2 is a rotating axis. What's like this rectangle? This rectangle is this side. We have this side is exactly this rectangle. So let me see. What's like a volume? Volume V is integral from A to B. The 2 pi times radius of a cylindrical shell and height of a cylindrical shell and dx, just like exact formula. So let me see. How can you find radius here? Center here, connect to the midpoint, or average radius, same. Here, you can connect to the rotating axis, this one. This is radius. This is like radius. What is radius? Could you write your answer? What is radius? Do you know what is radius? Radius is, do you know what is length? Radius, this one? Not 2x, so really be careful. From here to here. So this length is 2. This length is only x. Only x. 2 plus x. Radius is 2 plus x. What is height? Height is, I can use the orange one. This one, height. Height is exactly this one. This is the height. What is height? What is height? So could you write your answer on the chatting board? What is height? What is height? Yeah, no. So this one is going back to here. This one is here. Exactly this length or this point. This point is function value on the line. We have 2x. This point is point on the curve x squared. Exactly 2x minus x squared. This is what? 2x minus x squared. So answer is, from 0 to 2, 0 to 2, the 2 pi times 2 plus x times the 2x minus x squared dx. This is like whole idea for solving this volume problem. Like this. Like this one. Next tip. Find the volume of the solid obtained by rotating the region enclosed by y equals 2x and y equals x squared about y equals 6. How can we do that? So we can use the similar method. We can use like this here. We have y equals x squared. Y equals x, 2x, y equals 2x. So we have this intersection point is 2, just like 0. We have this region. The rotating axis is this one. So y equals 6. Rotate. The rotating axis is horizontal line. The horizontal line. So we can use the disc or washer method. Disc or washer. This one. So how can you make a disc or washer? We can use same things. The blue one. You can cut X and cut. We have this segment. This one. You have to rotate this segment about here. The y equals 6. Can you rotate? This point has big circle. This point make a small circle. We have a washer. So we have like a washer. The washer. Center is always rotating axis. This is center. Let me see. This portion is below 1. We have it like this. This one. You can find outer radius. So I can use green one. The outer radius is this one, is outer radius. From here to here. connect this segment here to here. Exactly, outer radius. What is outer radius? What's that? What's outer radius? Could you run your answer on the chatting board? Do you know outer radius? The outer radius is here. You can move to this one. This value is point on the curve, only x squared. So we have it. So from here to here, this length, what's that? This whole length is 6. And this length is x squared. What's that? Exactly 6 minus x squared. The 6 minus x squared is outer radius. 6 minus x squared. Like this. What's like inner radius? Inner radius is like orange one here. From here to here. Oh, sorry, only here. Not this one. Sorry about that. Not this one. Only this one. This one. What's that? Center here. Only connect to this one. This one is outer inner radius. We can move this one till this one. We have this length. What's that? Could you run your answer? What is length? Inner radius? Inner radius is, what is point? So this point is y value on the line. Line is y equal to 2x. This is 2x. Here 2x. So what's that? This length is 6 minus 2x. Here 6 minus 2x. We have 6 minus 2x is inner radius. So what's like a volume? The volume V is inner from 0 to 2. The pi times outer radius squared, 6 minus x squared minus inner radius squared, 6 minus 2x squared. So dx. This is like a whole idea for finding exact volume. So like this. We have it. Next one. Find the volume of the solid obtained by rotating the region enclosed by y equals 2x, y equals x squared about x equals 4. How can solve this problem? Here. You can use same graph, or the same graph. The y equals x squared is curve, this one. Y equals to 2x is line. This one. So we have y equals 2x is this line. Curve is y equals x squared. So this point is 2. This is like a 0. We have this region. You can rotate about x equals 4. X equals 4 is this one. You have to rotate. The rotating axis is vertical line. Vertical line. How can you find the volume? You have to use method of cylindrical shell. The vertical rotating axis is a vertical line. You can use method of cylindrical shells. The shells. You can use it. So what's that? The similar method. I can use blue one. You can cut x between 0 and 2. Here to here, you can cut this one. make a rectangle because we can use the cylindrical shell. You have to rotate this one about here, y equals 4. You can rotate this rectangle about x equals 4. So we have cylindrical shell. So we have cylindrical shell. We have cylindrical shell, so like this. So let me see what happens. So this rotating axis is same. This is center. This is like exactly the rotating axis. X equals 4 is rotating axis. The next one, this rectangle is this portion. This portion, this is like this rectangle, this portion. So same. Was it like a volume? The volume V is integral from A to B. 2 pi times radius of cylindrical shell. The radius of cylindrical shell times the height of cylindrical shell. dx. So this is a method. So let me see. How can you find radius? We can use green one. Here, radius is the center is this one and middle one. Here, center is here, connect to this point. This one. What is this length? What's that? Same to here. Is it move here to here? What is length? Could you run your answer on the chatting, please? What's that? So do you know answer? X plus 4. So let me see. What's it like a 4? 4 is from here to here. This is a 4. What is 1? This is X. So what's that? This is 4 minus X. 4 minus X. So we have radius is 4 minus X. The next we think about orange one. The orange one is height. Height is from here to here. This orange one is from here to here. What's that? You can move this one to here. This point, move here, and this point, this length. What's that? Could you write your answer on the chatting board? What is it like height? What's the height of a cylinder? Shell? Yes, this is on the line. This is x squared. The 2x minus x squared. This is 2x minus x squared. You're right. So what's it like volume? You know, from A is 0. The B is 2, is right? 0 and 2. 2 pi times radius is 4 minus x. Height is 2x minus x squared dx. So this is like a whole idea, like this. And simplify antiderivative, find answer a pi. It's like a whole idea for solving this kind of problems. Okay, this is like the idea for finding volume. What's the key? The rotating axis is the horizontal line. The rotating axis is a horizontal line. You have to use the washer or disc method. The rotating axis is vertical line. You have to use method of cylindrical shells. So yeah, this is like the all two-day lecture. Thank you for attending my class. I really appreciate. So if you have any trouble or any question, any kind of things, you can write your question on the chatting board. If you don't have any question, you can leave a live session. Okay, thank you. Oh, you're welcome.